Hello everyone, welcome to lecture 15. We will talk about sampling. I'm your instructor, Ms. Laura Lowe. We are in module 6 on week 6. This week we will talk about sampling and models. We only include 2 lectures for this week. Before that, remember in week 5 we talk about simulation and chances, but you can think about the chances actually is the probability. So we introduce the probability. That's what kind of the heads up before we can talk about sampling. So we have different kind of sampling. Then we will also talk about distribution in this lecture. So the next lecture we will continue to talk about models. Before we moving forward to the new topic, let's do a quick review from what we covered last week. So we talked about probability last week. So here we have 2 discussion questions. I want you to work on that. So remember that's a recorded lecture. So maybe I don't have time to reserve for you to discuss. So I'm very welcome and encourage you guys. Maybe find your group from your lab exercise peer group or any classmates. Maybe you guys can find time together to watch the lecture video together. Maybe through the Zoom, maybe in our student center. So then you can pause the video and think the discussion question. Or if you couldn't do that by yourself, whenever you see a discussion question, maybe pause the video, right? So for now, pause the video and read first. Then of course later I will provide you the answer. So the discussion question, we have 2 questions. We have a population for 100 people, including Rick and Morty. Again, our population, we have the random we sample by random without any replacements. So we want to pick up 2 persons from this 100 people. So from that, we have question. The first one, from the 2 people you random select, if neither Rick nor Morty in that sample. That means when you draw 2 persons, they are not Rick and they are not Morty. So what is the chance? Then the second question is, the 2 persons you choose, they exactly are Rick and Morty. So what the chance? So please pause the video, then I will give you the answer. So remember last week when we talked about the probability, we talked about the multiplication rule and addition rule. So multiplication rule, you can think about actually in the event you have, sometimes they have different steps, right? So you have step 1, you have 1 outcome, then step 2, you have 2 outcome. Then they need to happen next to each other. So that's we do the multiplication. So then addition rule is like what? Like you have an event will be happen, but they have different combination. And multiple combination meet the event you ask for. So then you add all the chance for all different outcome. So in this question A, neither Rick nor Morty in the sample. We can think about when we random select 2 persons. Just think about even we draw at the same time. We still think about you have the first one and the second one. So on the other hand, we have the first person is not Rick or Morty. Then the second person are not Rick or Morty. So then these 2, what the chance is. Okay, so let me write it down here. So the first person is not Rick. So we have 100 people, right? So we have 98 are not Rick or Morty. Okay, so that's why here you see the first person, not Rick or Morty, that's 98 out of 100. So after I choose this person, the second person, I only have how many people left? I only have 99 people. Then I need to choose 1 person, but they are not Rick or Morty. So that's why you only have 97 to choose from. Okay, so like we say, you choose the first person and the second person. So that's why we use what? Multiplication rule. Okay. Okay, so my drawing is ugly, so I will exit the drawing. Then I will show you the next answer. But before I go to the next page, I just want to do the second one. Okay, the second one, we say these two persons, exactly Rick and Morty. So the same thing we need to think about. You draw one person, then the second person. So that's why they have two combinations. The first one is Ricky, then the second one needs to be Morty. Or the first one I draw is Morty, then the second one is Ricky. So you see that two combination meet. The two persons are Rick and Morty. So that's plus together. Okay, so that's why here, for the second answer, remember, you need to be Rick and Morty. Or Morty or Rick. So the first one needs to be Rick. You see only one Rick out of this 100%. After Rick is picked, only one person I want to pick because they need to be Morty. Then you only have 99%. So the same thing for the Morty first and Rick will be 1 out of 100 times 1 out of 99. So then we calculate. You can run like this. You can either use calculator or Python is your good friend, right? Okay, so then you see the first one, 98 divided by 100 times 97 divided by 99. Okay, so that's your chance. So mostly, yeah, so the answer we show you is 4 digit in decimal. That's just because usually you say 98%, 98.02%. So how many digits you need to specify when you do your homework or midterm exam? For the homework, you just according to the Python output. For the midterm exam or something, just check what we ask you to answer. Yeah, so that's our review for our probability. And I think in the slide we still including the Monty Hall problem. So the Monty Hall problem actually we already discussed about that. That's usually in a game show. There asks the person to see they have beginning have 1/3 chance to get the car because they have 3-door choice. Only one door behind that is car. The other 2 will be goat. So they like to play this way. After your choice, beginning only have 1/3 choice to get a car, right? But no matter which door you choose, the game show host always can open one door. It's not the choice you want, right? You want the car. So they can show you the goat. Then they will ask you, hey, I show you the goat. Now I give you another chance. Do you want to switch your choice or stay? Okay, so this one we will talk about, we proved that for you. Because according to the beginning choice and your end choice, they will be like that, right? So here is the original choice. No matter which one you do, we always can have the game show host reveal. Okay, so that's if you choose the first goat, then they can show you the second goat. Then the other door, if you switch. So other choice is you switch. That's your result. So the same thing, even you choose card, then we have either goat 1 or goat 2. I can show you. But no matter what, the other choice is either goat 1 or goat 2. So this one actually we told you beginning your choice to get the car is 1/3, right? Because you have 3 doors. Then your result changed. The reason is they changed the condition. Okay, anytime your probability, the condition change, they will change all the possibility for your outcome. So that's the reason you change your chance to get the car. So that's why we prove to you. They just ask you, stay, right? So if you stay, that's your original choice. When you stay, you always just have 1/3 chance to get the car. But other choice is what? Because after they reveal that door with goat, your result changed. because the other choice, the other door is changed. So that's why here is your state. If you want to stay, you still only have 1/3 chance to get a car. But if you decide to switch, did you see you still have 3 doors, right? But actually, the chance is 2 out of these 3 doors are cars. So that's what we call the famous multi-hole problem. Because after the potential holes revealed that goat, your possibility changed. That's why I want to quickly, because at the end of the last lecture, I didn't really talk about very clear. So that's our lecture 14 on the sample file we show you, right? After we simulate 10,000 times using Python. Okay, so that's why we give you the table. You can see your original choice. They kind of, this 10,000, yeah, you see almost like 3,300. Yeah, they got for all the 3 choice. Yeah, they are all the 3 almost 1/3. But if you switch to the remaining door, then you can see actually this one, yeah, only the car, the choice kind of is 60. You see that 66, 86. So that's almost 2/3 chance. So on the other hand, the other 2, they are not 1/3. They become 1/6 because they share that 1/3. So that's why we show it in the histogram. So that's why you can see the blue is your original. They are all similar chance is 1/3. But if you decide to switch after the reveal, your chance to get the car actually become 2/3, almost 2/3. Okay, so that's the review for our probability. So I still have 3 minutes on this video, so let's quickly give you the definition about sampling. Okay, so probability is prepared for our sampling. So what is sampling? When we talk about a sample, basically it's a subset of the population. Okay, so the population, you can see like all the students in DVC. So the sample is what? I want to choose 10 out of all the DVC students. Okay, so that's the sampling. Before we talk about sampling, we want to focus on random samples. But we still give you the definition for 2 different samples. Okay, random sample is we want to achieve. But sometimes a lot of sample people think they are random sample, but they are not. So we just talk about you have the other sample you call deterministic sample. So deterministic sample is what? The sampling scheme doesn't involve chance. So what does that mean? That means, like earlier I said, I want to, all the DVC students, I want to choose 10 students. So then I only choose from our data science class. Okay, so that's not involve the chance. Or I just say, we do the other one, we maybe say the more computer science course. Because data science actually we have more major. So then maybe like my advanced class, the assembly language, I choose all the students from there. So then, yeah, basically all of them are CS students. So that means the sampling scheme doesn't involve chance. Okay, they kind of in the same population. So that's why for the data science, when we want to analyze data, we want the random sample. So what is random sample? Before the sample is drawn, you have to know the selection probability of every group of people in the population. Not all individual or group have the equal chance being selected. Yeah, what does that mean? That means you need to know well for your population. Because like earlier I said, I want to choose the people from DVC students, right? For our DVC students, we have students, they have night class, evening class, morning class, or they are in different classrooms. So then if I want to really do the good random selection, I cannot just say, oh, I go to ATC classroom 115 to choose a student. Because they're usually just a CS student. So I need to know more about my population, how the DVC student will be there. So we need to have more random select from there, not certain time.